friends, welcome back. This unit is all about solving polynomials, and in order to do that, you're going to need to know how to factor them. And there is one way that you can factor that is kind of complicated, and we'll get into it in this unit, and that will work every time. However, I want you to be able to identify these other ways of factoring polynomials or solving polynomials. So that way if it makes it a little bit easier, so you're not having to do the long method every single time. So these are what I like to call special cases. So let's dive right in. For our first one, we have sum and difference of cubes. Sum and difference of cubes. So if you take a look here, if we've got two perfect cubes, we would have, so let's write it like this, x to the third minus 4 to the third, because 4 to the third will give us 64. So we have perfect cube minus perfect cube. We can go ahead and factor that using our difference of cubes. And the way that that works is you take x and 4, that's going to go right here. Notice I'm not putting my signs in. We're going to do that last. Then we're going to do x squared in the front and 4 squared at the back. So that's going to be 16. And then we multiply these two things together to give us 4x. Now, I can never remember my signs for sum and difference of cubes. And here's all you have to remember is SOAP. And that means same sign, opposite sign, always positive. So the same sign as this one, minus, opposite is addition, and then this last one is always positive. Okay, so now that we've broken this down, we can solve it further. So looking at this guy, whenever we use our sum and difference of cubes, that trinomial that you get is not going to be a real solution. So we could use our quadratic formula to solve for that part. But let's do our zero product property. Words are hard. Zero product property to say x minus 4 equals 0, which means x equals positive 4. Now, this, like I said, let's go ahead and use our quadratic formula, and I think that'll help you understand where I'm coming from. Now, our quadratic formula is x equals negative b plus minus the square root b squared minus 4ac all divided by 2a. When I use my quadratic formula, I like to start with my discriminant, the stuff underneath, first. B squared minus 4ac, because that's where everybody makes their mistakes. So 4 squared minus 4 times 1 times 16. So you'll see we have 16 minus, and then if we do 16 times 4 will give us 64. And then minus 16 on that. So we would get negative 48. Negative 48. So as I mentioned, when you're using this, you're not going to get a real answer for this last part. And negative 48 means our discriminant is negative, which means we're not going to have a real solution. But we are now ready to use our quadratic formula if we wanted to continue going that way. X equals negative b plus minus the square root of our discriminant, which we know is negative 48, all divided by 2 times a, which is 1. So all divided by 2. Okay, so negative 48, let's break that down. We're looking for a perfect square that's hidden in there. So what we have, let's do a little side work here. Negative 48, the square root of negative 48 is really the same as our largest perfect square is 16, 3, and negative 1, right? 16 times 3 times negative 1 will give me negative 48. Well, the square root of 16 is 4. The square root of negative 1 is I, and the square root of 3 I can't really do anything with. So this is x equals negative 4 plus minus 4i root 3 over 2. And I know you think we're probably done, but we're not. We've got to scooch right over and do a little bit more. You'll see that these three things have something in common. This, and this all have a 2 in common, which means we can factor out a 2. So if I write that over here, x equals 2, and that would be negative 2 plus minus I root 3 over 2. Now I can factor those guys out, and I am left with, oh, oops, that should have been, I didn't see the 4 there. That should have been a 2 here. So I am left with negative 2 plus minus 2i root 3. So pay attention to, so x equals all of that, right? So pay attention, because a lot of times it'll say find all the real solutions. And if that's the case, when you're doing your sum and difference of cubes, you don't have to do this last part. But when we get to this point, we also want to ask ourselves, so this is x equals, right? We have one solution here, and then we have two solutions here. We have negative 2 plus 2 and negative 2 minus 2i root 3. So we have one solution here, 2 solutions here for a total of 3 solutions. How many solutions do we have? 3. How many should we have? We go and we look at our highest exponent, 3. If you don't have 3, you should know why, and that'll come up a little bit in a future video. So that's sum and difference of cubes. Let's talk about factoring by grouping and solving polynomials that way. All right, so if we group this guy and this guy, in our first group there, we can take out n squared, which leaves me with n plus 5. Bring down that minus sign, and we can factor out a 9 from that, and that leaves me with n, and again, do not bring down this negative sign because a negative times a negative would give us a positive, and we need a negative there, so it's plus 5. Ask yourself if these two things are exactly the same, and in this case they are, so if that was a negative, that's where you will have messed up, because a negative times a positive gives us a negative. So this is our first, so we have n squared minus 9, and then we have n plus 5 equals 0. Let's use our zero product property to say, okay, n squared minus 9 equals 0. We can solve this by factoring because it is a difference of squares, or we can do it by adding 9 to both sides to get n squared equals 9, square root both sides, and we get n equals, remember when we take something out of the radical, plus minus 3. Over here, n plus 5 equals 0, minus 5 from both sides, we get n equals negative 5. Okay, so how many answers do we have? 1, 2, 3. How many answers should we have? 3. We have done this correctly. Okay, so let's take a look at some of these other ones. We have difference of squares here. So for difference of squares, and I know it seems kind of weird because we've got a 4 here, but what we can do is we would say a couple different ways of doing this. So we could say this, x squared minus 9 squared equals 0, right? So when you have a perfect square, so perfect square minus perfect square, that factors to be x squared plus 9, x squared minus 9 equals 0. Okay, so now that we have x squared plus 9, x squared minus 9 equals 0, I'm actually going to write that over here so that we can have a little bit more room. I get a little excited when I'm writing and I run out of room. Okay, and so x squared minus 9 equals 0. So use our zero product property. We say x squared plus 9 equals 0, which means x squared equals negative 9. Square root both sides, we get x equals plus minus, because we're taking it out of the radical, and that's a negative 1 underneath there, so this is going to be 3i. Over here we have x squared minus 9 equals 0, which means x squared equals 9, which means x equals, square root both sides, we get x equals plus minus 3. So how many answers do we have here? 1, 2, 3, 4. How many answers should we have? 4. It doesn't always work out perfect like that, but you should at least know why you don't have as many answers as you should. All right, so another type is to convert it to a quadratic by factoring. So we come here and we look at this guy and we see, oh, hey, this will be nice and friendly because they all have an x in common. So we can take out an x, and that leaves us with x squared minus 6x minus 72 equals 0. Let's use our zero product property here to say x equals 0. That one's easy. Now over here, we can factor this guy. We can say x, this tells me different signs, so I need a positive and a negative. So I need a positive and a negative that will give me factors of 72 that will give me a negative 6. I listed all my factor pairs here, and you'll see I have 6 and 12. So if I do a positive 6 and a negative 12, that will equal negative 6. So positive 6, negative 12. And now let's use our zero product property again. X plus 6 equals 0, which means x equals negative 6. And x minus 12 equals 0. Add 12 to both sides, we get x equals 12. All right, so how many answers do I have? 3. How many should I have? 3. Beautiful. Let's see a couple more of these special equations. So type 5. So we can convert it to a quadratic by substitution. The last one we just converted to a quadratic by factoring. This one we're doing some substitution. And what we mean by that is So you'll see that we have a trinomial here, and this guy in the center is exactly half of this one. So let m equal x squared. And what that lets me do is now I can say, I'm going to rewrite this guy, m squared minus 13m plus 36 equals 0. And this is much friendlier. We look at that and we're like, hey, we know how to do this. We can just factor, right? So we say there's 0, m. This tells me same signs. This tells me negative, negative. Factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. I need a negative negative that gives me negative 13. Well, if I do negative 4, negative 9, that adds up to negative 13. So negative 4, negative 9. Okay, so that means m, using our zero product property, m equals 4 and m minus 9 equals 0. So m equals 9. But wait, remember, m equals x squared. So we have m equals 4 and m equals 9, except x squared, we can substitute that back in for our m. So, and then x squared equals 9. Square root both sides, I get x equals plus minus 2. Square root both sides, and I get x equals plus minus 3. So I have 2 answers here and 2 answers here, for a total of 4 answers, and I go and I look at my original problem. How many should I have? 4, so I've done this correctly. All right, factor by grouping. Factor by grouping. So in this case, I think I actually did a factor by grouping, so I apologize. We don't have to do this one again. I got excited and I wanted to write it down another time. But what I do want to do is factor by grouping with factoring completely. Factoring completely. If you ever see the instructions, factor completely, you will see that they are your teacher is trying to trick you, okay? So let's factor this by grouping. And what do I mean by factor completely? So if I take this and I take out an x to the 4th, that's going to leave me x minus 3. Minus, now 16 and 48 both have 16 in common, and that leaves me with x, again, minus 3. Don't just bring down that plus sign. We want to take out a negative, because a negative times a negative will be a positive. Equals 0. Whoops, I was supposed to put an equal 0 there. So I have, this is one of my terms, x to the 4th minus 16, and then I have x minus 3 equals 0. Let's use that zero product property. Actually, I'm going to rewrite this so that this is over on the other side. X minus 3, x 4th minus 16 equals 0. So use our zero product property, x minus 3 equals 0, which means x equals positive 3. Let's get that guy out of the way. Now we have this one, x to the 4th minus 16 equals 0. Remember, this is a perfect square minus a perfect square. It's x squared squared minus 4 squared equals 0. So that factors to be x squared plus 4, x squared minus 4 equals 0. So now let's use our zero product property again, and we have x squared plus 4 equals 0. Subtract 4 from both sides, and I get x squared equals negative 4. Square root, and I get x equals plus minus, because I'm taking it out of the radical. Now, the square root of 4 is 2, but there's a negative there, so it's 2i. So that's my imaginary number. Over here, I have x squared minus 4 equals 0, which means x squared equals 4 if I add 4 to both sides. Square root both sides, and I get x equals plus minus, because I'm taking it out of the radical, 2. Square root of 4 is 2. So I have 2 answers here, 2 answers here, 1 answer here. That's 5 answers. How many should I have? 5. So I've done this correctly. So what I mean by factoring completely is usually when you see the word completely here, that means that it's like a double step, and that's where this double step was. There was another one hidden in here that we could factor. So keep those in mind as you're factoring these polynomials. I think that will help as you learn how to fully factor these polynomials. Keeping these little tips and tricks and special cases in mind might help. Good luck, and we'll see you next time.